This is Gigafactory, Texas, one of the most advanced automotive manufacturing facilities ever built, spanning over 10 million square feet. This factory can produce over 500,000 electric vehicles per year. Today we're taking you inside for an unprecedented 30-minute journey showing exactly how Tesla builds the cars that are transforming transportation worldwide. Hey everyone, I'm Marcus, and I've been with Tesla's production team for 5 years. What you're about to see isn't traditional car manufacturing, this is the future. Tesla builds vehicles differently than any other automaker. More automation, more vertical integration, and a completely electric powertrain that's revolutionizing the industry. We'll follow one Model Y from raw materials to road-ready vehicle. This factory operates 24/7, producing one car every 45 seconds at peak capacity. Hit subscribe because this is unlike anything you've seen before. Let's go build the future. Tesla's production philosophy is radically different. Traditional automakers assemble cars from thousands of parts made by hundreds of suppliers. Tesla vertically integrates. We design and manufacture batteries, motors, computer systems, even seats, and this level of control allows unprecedented innovation speed. See those robots, over 2,000 working in this facility alone, alongside 10,000 plus human team members. Let me show you where it all starts. From Earth's elements to electric revolution, let's trace every step of the journey. This is how Tesla builds tomorrow, today. Tesla was founded in 2003 with a mission: accelerate the world's transition to sustainable energy. What started with the Roadster, proving EVs could be fast and desirable, evolved into the Model S luxury sedan, then Model 3 mass-market vehicle, and Model Y, now the world's best-selling car. Traditional automakers said electric vehicles couldn't be profitable. Tesla proved them wrong by rethinking everything: battery technology, manufacturing processes, software integration, and direct-to-consumer sales. Today, Tesla isn't just an automotive company, it's an energy and AI company building the future of transportation. Internal combustion engines are mechanical marvels but also incredibly inefficient. Most energy from gasoline becomes waste heat, not motion. Electric motors convert over 90% of energy to movement. No transmission, no oil changes, no emissions. Simplicity means reliability. And as electricity grids get cleaner with solar and wind, EVs get cleaner too, something gas cars can never do. This efficiency revolution starts with one component: the battery. The Gigafactory isn't just big, it's strategically designed for maximum efficiency. Everything flows in one direction. Materials enter, vehicles exit. By manufacturing batteries and vehicles under one roof, Tesla eliminates shipping delays and costs. The factory itself is designed to run on renewable energy with solar roofs and battery storage. It's a factory that builds the future while being powered by it. Just-in-time manufacturing at this scale requires incredible logistics, precision. This dock receives over 200 truck deliveries daily. Every component is tracked in real. The factory's AI system predicts material needs 72 hours in advance, automatically ordering from suppliers. One delayed shipment could stop production. So redundancy is built into everything. Tesla uses aerospace-grade aluminum alloys for body panels, lighter than steel but equally strong. Weight is the enemy of electric range. Every kilogram saved means more range for customers. This aluminum will become body panels, structural components, and battery enclosures. But the most critical raw material isn't metal. It's what powers the vehicle. Battery chemistry starts with Earth's elements. Lithium-ion batteries need lithium, nickel, cobalt, and graphite. Tesla is working to eliminate cobalt entirely due to ethical mining concerns and is developing lithium iron phosphate chemistry for certain models. The company is even planning to extract lithium from Nevada clay deposits. Vertical integration extends to raw materials, controlling the entire supply chain from mine to motor. Quality starts before production begins. Every material batch is tested against strict specifications. Aluminum must meet exact strength-to-weight ratios. Battery materials require 99.9% plus purity. There's no room for compromise. These materials become safety-critical vehicle components. Now that materials are verified, let's see how they transform into the world's most advanced battery packs. This is where the heart of every Tesla is born, the battery cell manufacturing facility. Tesla's latest 4,680 cells are revolutionary. 5 times more energy than previous cells, 6 times more power, and 14% increase in range. Larger cells mean fewer cells per pack, reducing complexity and cost. Let's see how these technological marvels are made. Battery manufacturing is as much chemistry as engineering. The coating must be perfectly uniform. Variations of even micrometers affect performance. The electrolyte is moisture sensitive. Even 10 parts per million water content can cause premature aging. Every cell is charged, tested, and tracked. Only cells meeting Tesla's strict specifications continue to the next stage. Failure rate must be below 1 in 10,000. Battery pack assembly is robotic poetry. Over 4,000 cells must be placed with perfect alignment. The pink thermal compound transfers heat to the cooling system, critical for safety and longevity. Tesla's structural battery pack design is revolutionary. The battery isn't just energy storage, it's a structural component of the vehicle, eliminating redundant materials and reducing weight by 10%. This is the single most valuable component of the vehicle, representing about 30% of total cost. The battery management system is the brain protecting this energy-dense component. It monitors every cell group's voltage and temperature thousands of times per second. If any cell shows abnormal behavior, the BMS can isolate it and alert the driver. This system enables safe fast charging at Tesla superchargers, delivering 200 miles of range in 15 minutes. Battery safety isn't an afterthought, it's engineered into every level. This battery pack is now sealed, tested, and ready for installation. It's waterproof, crash protected, and designed to last the vehicle's lifetime over 300,000 miles with minimal degradation. This pack weighs nearly 500 kilograms but stores enough energy to power the average home for several days. Now it's ready to meet its vehicle body. This is Tesla's most revolutionary manufacturing innovation, the Gigacasting. Traditional car manufacturing would require welding together 70 separate stamped steel parts to create the rear body structure. Tesla's Gigacasting creates the entire rear section as a single aluminum casting in just 90 seconds. This eliminates hundreds of robots, welding equipment, and factory floor space while improving structural rigidity. It's the same technology used for toy cars, just scaled up to automotive size. Let me show you how it works. Watch the transformation molten metal to structural component in 90 seconds. The Gigacasting operates with micron-level precision despite the tremendous forces involved. This single casting reduces manufacturing costs by 40%, factory footprint by 30%, and part count by 95%. But it requires perfect metallurgy. Tesla developed a custom aluminum alloy that's strong, castable, and recyclable. This isn't just manufacturing innovation, it's materials science breakthrough. While rear and front underbodies use gigacasting in newer factories, body panels still require traditional stamping for their complex curves and class A surface finish. Tesla uses aluminum extensively. The Model Y body is over 80% aluminum, reducing weight while maintaining safety. Newer gigafactories are implementing front casting too, moving toward a vehicle with just 3 main structural pieces: front cast, structural battery, rear cast. Even revolutionary casting requires precision finishing. Every mounting hole must be within 0.5 mm tolerance. Surfaces are machined to exact specifications. Parts are cleaned and inspected before entering the body shop. This level of precision ensures perfect fit when components come together. Speaking of which, time to build the body structure. Welcome to the body shop, where over 600 robots work in perfect harmony. This is the most automated part of Tesla's factory with 95% plus robot operation. Each vehicle body receives over 5,000 welds with 99.9% accuracy. The orchestration is computer controlled. Every robot knows exactly where every other robot is, moving in synchronized precision. Human workers monitor, maintain, and program these robots, but rarely touch the vehicles themselves. This is manufacturing at a scale and speed impossible for human hands. The underbody assembly is precision engineering. Front and rear sections must align within half a millimeter. Tesla uses 3 joining methods: structural adhesive for rigidity, spot welds for strength, and self-piercing rivets for aluminum joints. The result is a body in white that's incredibly stiff, critical for handling dynamics and crash safety. This structure is engineered through supercomputer simulation to protect occupants while minimizing weight. Body assembly happens in stages but flows continuously. One vehicle body completes every 45 seconds. The precision is stunning. Panel gaps are held to within 2 millimeters, creating the flush appearance Tesla is known for. Notice there are no workers touching the vehicle. It's too dangerous with robots moving at these speeds. Human safety is paramount, which is why automation isn't just about efficiency, it's about protecting workers from hazardous tasks. The body shell is now complete and structurally sound. It's been welded, reinforced, and inspected. Before paint, it will be cleaned and treated to ensure perfect paint adhesion. This bare metal shell weighing about 300 kilograms will soon gain color and personality. Let's follow it to the paint shop. Paint isn't just about aesthetics, it's corrosion protection. Tesla warranties vehicles against rust perforation for 12 years, but the goal is generations of durability. The E-coat electrodeposition process coats every surface, including closed cavities, where traditional spray painting can't reach. This primer layer is the foundation of the paint system. Now for the color. Tesla's robotic painters apply base coat with superhuman consistency. Electrostatic charging causes paint particles to wrap around surfaces seeking ground, ensuring even coverage and reducing overspray waste by 60%. Paint thickness is controlled to within micrometers. Too thin and coverage suffers. Too thick and it runs or adds unnecessary weight. Each color has different application requirements. The multi-coat finishes like pearl white and red require multiple layers to achieve their characteristic depth and brilliance. Clear coat provides UV protection, chemical resistance, and that showroom shine. It's the most critical layer. Any defect is visible. After curing at 140 degrees Celsius, the paint system is fully hardened and incredibly durable. But paint perfection is difficult. About 10 to 15% of vehicles require minor spot repairs for dust inclusions or application imperfections. Tesla's paint quality has improved dramatically, but remains an area of continuous focus. Paint perfection requires human artistry combined with robotic precision. Once approved, this body is ready for the final stage, becoming a complete vehicle. It's traveled through extreme heat, chemical baths, and precision painting. Now it's time to add everything that makes it a Tesla: the battery, motors, computer systems, interior, and glass. Let's watch it come alive. This is called the marriage body meets battery. With over half a ton of battery being installed, precision is critical. The battery isn't just a power source, it's a structural component, meaning the vehicle's stiffness depends on this connection. Bolts are torqued to exact specifications. Too loose and vibration causes problems. Too tight and thread strip. This isn't assembly, it's precision engineering. Electric motors are elegantly simple compared to internal combustion engines. The rear motor provides efficiency, permanent magnets for maximum range. The front adds power, induction design for high performance. Together they create all-wheel drive with no mechanical connection between them, just software coordination. No transmission, no drive shaft, just electric simplicity. These motors will produce 450 horsepower and can last the vehicle's lifetime with zero maintenance. The chassis components give Tesla its legendary handling. Adjustable suspension can raise for snow or lower for efficiency. Regenerative braking recovers up to 70% of braking energy. Friction brakes are almost backup systems. Every component is torqued and aligned with precision. The vehicle is starting to look complete, but the brain is still missing. This is where hardware becomes intelligent. The Autopilot computer processes data from 8 cameras analyzing the world 36 times per second. The touchscreen runs everything: climate, media, navigation, vehicle settings. Traditional cars have hundreds of physical buttons. Tesla uses software interfaces. The interior is minimalist by design, reducing complexity and focusing on the essentials. The screen and the road ahead. End-of-line testing is exhaustive. Every electrical system, every safety feature, every sensor must function perfectly. The water test ensures the vehicle can handle severe weather. Brake testing verifies stopping power. And charging verification ensures the vehicle can accept Tesla Supercharger's maximum 250 kilowatts charge rate, adding 200 miles of range in 15 minutes. The road test is the final verification. Does this vehicle meet Tesla's standards? Inspectors have years of experience knowing how a perfect Tesla should drive, sound, and feel. Only after passing over 1,000 individual quality checks does a vehicle earn approval. This Tesla, built over the past 24 hours, is now ready for its owner. Time to ship. From this factory, Teslas reach customers nationwide within days, some via truck, others by rail. Tesla's direct sales model means no dealerships. Customers order online and take delivery at company-owned centers. This vehicle we followed will join over 5 million Teslas already on roads worldwide, collectively driving over 100 billion electric miles and preventing 15 million tons of CO2 emissions annually. And that's how Tesla builds the future, from lithium in the earth to a 500 horsepower electric vehicle in your driveway. We've seen revolutionary manufacturing, single-piece gigacasting replacing 70 parts, batteries assembled by the thousands, over 600 robots welding with precision impossible for humans, and integration levels other automakers are just beginning to understand. But this isn't just about building cars, it's about accelerating sustainable transportation. Every Tesla produced brings us closer to a world running on clean energy. Manufacturing at this scale, with this level of automation and quality, is what makes electric vehicles accessible to millions. This is just the beginning. Next-generation platforms will be even more efficient, more automated, and more sustainable. Thanks for joining me on this journey. Hit subscribe for more manufacturing deep. Until next time, drive electric, drive the future.